Hello everyone, today we are learning the subject of circuit theory. Here Prof.Sumera Ali. So we will see the chapter of your electrical network parameters and the passive network, and we will simplify the numerical on the basis of your the derived method as well as the constant K. So let's see the numerical number 1. Same thing, how we can start ml by 2. So substitute the value of m, substitute the value of l, and the 2 you will get the answer of a 0.019 Henry. The MC, that is a 0.435 already we have done, and the C value is a 0.35 micro, so you will get the 0.154 microfarad. Now go for the 1 minus m square by 4m into L, so you will get 0.041 Henry. Similarly ml, the MC by 2, so substitute the value of ml, likewise the substitute the value of mc and the 2, you will get the answer. So all the parameters which is related to the T section, which is related to the pi section, you need to calculate and you need to substitute in the figure, or you can say the designing part, that is nothing but the T and the pi section, or you can say the series and the shunt arm. The next numerical ml by 2, you can find so L is nothing but the 2 into 0.05 divided by m, so here will be 0.1 into m. So substitute this L value in the second expression, that is third expression, that is 1 minus m square by 4m, and here is the L value. L is nothing but 0.1 into m. So likewise the unknown parameter is nothing but the m, that and equals to 0.06 already mentioned in the third expression. So in this way you can find the unknown parameter, that is nothing but m, and you will get 0.5423. Substitute this m value in the any one of the expression, either the first and the second, you will find the inductor value, that is a 0.1844 Henry. Now you can substitute this value in the any one of the second expression, so you will get the capacitor unknown value, that is nothing but the 0.922 microfarad. So switch toward the next the value, that is nothing but that is design impedance, which is design impedance is equals to K is equals to root of L by C. So substitute the L value, substitute the C value, you will get 447.2 ohm. The cutoff frequency is equals to FC is K by divided by pi into L, that is a 447.2 pi into 0.1844. So you will find 771.98 Hertz. The last part is nothing but the frequency of infinite attenuation, denoted by F infinite is equals to FC divided by root of 1 minus F square. You have the value of FC, you have the value of M. Substitute this value, you will get 918.817 Hertz. So likewise, you have calculated all the points of your the designing component L, C as well as the M, apart from your the design impedance, cutoff frequency and the M, F infinite. Go for the next numerical. So just be remember the given parameters. The K is given, the FC is given, the M is given. Now find out the inductor. L is equals to K divided by 4 pi FC. See here the difference between the low pass and the high pass, the formula for the inductor and the capacitor, and even all other formulas. So they are different. So here the K divided by 4 pi FC, 200 divided by 4 pi into this 1000, you will get the inductor 0.0159 Henry. C is nothing but 1 by 4 pi into FC into K, 1 by 4 pi into 1000 into 200, so 0.398 microfarad. 2C divided by M, substitute the value of the C, substitute the value of the M, you will get 1.59 microfarad. Then the L by M is nothing but 0.0159, 0.5, likewise the Henry, and this one, that is a 4M divided by 1 minus M square. Substitute the value, you will get 1.061 microfarad. The remaining part is nothing but the C by M, that is nothing but in the pi section. So always start with the T section, the unknown parameters, just like the 2C by M, the L by M, and the 4M divided by 1 minus M square into C. Then go for the pi section. So here the C by M, then the 2L by M, then the 4M divided by 1 minus M square into L. Likewise, you can find the T2, the pi unknown parameters, and you can substitute the values. So last parameter, frequency infinite attenuation, F infinite, FC into root of 1 minus M square. So here you will get 866 Hertz. Go for the next numerical. Here this numerical is related on the constant K. This is a somewhat different numerical which we have seen in the previous one. So here the design of the constant K low pass filter of the pi and the T sections at a frequency of 5 kilohertz, and the design impedance of the 1000 ohm. Calculation of your the attenuation constant at a particular frequency and the phase shift at a particular frequency, which particular 6 kilohertz and 1 kilohertz. The Filter is a low pass filter. The method is a constant K instead of M derived, and the sections are T and the pi. So see here the T and the pi section. So here L by 2, L by 2 series arm, and the capacitor is a shunt arm, whereas the L is the series arm in the pi, and the C by 2 are the shunt in the pi section. So we need to calculate L by 2, we need to calculate the C by 2. So here the given is nothing but cutoff frequency of 5000 hertz, design impedance is the 1000 ohm, L is equals to K by pi into FC, just because of the low pass and the constant K. So here the K value, pi value, and the FC value, you will get 63.66 millihenry. The capacitor value 1 by pi into FC into K, 1 by pi 5000 and the 1000, you will get 60 nanofarad. Now, but the thing is that we are interested L by 2 and the C by 2. So L by 2, whatever you are having divided by 2, and whatever you are having the C, just divided by 2. These two values just substitute at the designing section. Now, what is the additional part is here? Calculation of the attenuation constant, that is alpha is equals to 2 cos hyperbolic inverse of 2 cos hyperbolic inverse of normal frequency divided by the cutoff frequency. So normal, that is f by fc. Normal frequency is the f, that is at the 6 kilohertz we need to take, and the fc is nothing but the 5000. Likewise, you will get 1.245 in the nipper, and the phase shift constant is nothing but the beta. Beta is equals to 2 sine inverse of f by fc again. So f is nothing but normal frequency at a particular, that is a 1 kilohertz, fc is the 5000, so you will get 23.074. So this is in the degree, and this is one in the nipper. Go for the last numerical, which is related to the low pass filter of the constant K. So element of the T section of the constant K of low pass filter are shown here. Inductor and the capacitor value is given, that is 50 millihenry and the 0.01 microfarad. We need to calculate the cutoff frequency and the pass band along with your the impedance. So how we can start? See here, the only the T section is given, L by 2, L by 2 and the C. The filter is a low pass filter, the method is the constant K, the section is the T. So all these things you need to write, be remembered before going to start the session. You always write the filter name, you always write the method, you always write the section. Later on the given values. So what is given in the numerical? L by 2 is nothing but the 50 millihenry. The capacitor value is 0.01 microfarad. The substitute, how you can find the L will be equals to 50 into 2, that is nothing but the 100 millihenry. Capacitor is 0.0 microfarad. Likewise, the find out the cutoff frequency FC is equals to 1 by pi root of LC. So here the L and the C value is given, you can find the cutoff frequency. Now for the pass band, the frequency is ranging from the 0 to this 10065.84 hertz. Now go for the nominal or the design impedance, which is equals to K is equals to root of L by C. So you have the L value, you have the C value, that is in the what we can say millihenry and the microfarad. So you can divide, and in the root you can take that root, and you will be able to find 3162.28 ohm. In this way, we have seen the what you can say the numerical on the basis of your the filters, low pass, high pass, with a constant K, as well as the M derived filters, and we have calculated the designing part of the T and the pi section by looking the figures and all unknown parameters. In this way, few numericals we have solved. Thank you so much.